Now let's consider the question, how do we find a point and a normal vector for the plane 4x plus 6y minus 5z plus 12 equals 0? We know that the form of the equation of a plane is a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. And the normal vector is ai plus bj plus ck. So that a is going to be the coefficient of x. In this case, a is going to be 4. B is the coefficient of y, making b equal to plus 6. And c is the coefficient of z, so that c equals negative 5. X naught, y naught, z naught can be any point that lies on this plane. So one thing we can see for sure is that our normal vector is 4i plus 6j minus 5k, meaning again that any vector between any 2 points of the plane has to be perpendicular to this normal vector. Now to find a point on the plane, because if we have the normal vector and a point on the plane, we can put it into this form, or we can do as before and make ourselves a sketch to make sense of the situation, and we can find the entire equation of the plane. So let's let x naught equals z naught equals 0, and following techniques that we used a minute ago. Not going to go through the details, just saying that if we let x and z be 0, then we have 6y plus 12 equals 0, giving us y equals negative 2. So the point x naught, y naught, z naught equals 0, negative 2, 0 is on the plane. And we can then, let's go ahead and just use this form, although I do recommend drawing it out as we've done in previous discussions. We're going to get 4 times x minus 0 plus 6 times y minus negative 2 plus, excuse me, writing this down without thinking, that's going to be, cost myself $1 here, minus 5 times z minus 0 equals 0, giving us the equation 4x plus 6y minus negative 2 is plus 2, so we're going to have plus 12 minus 5z equals 0. And we see that this equation, except for the order of terms, is identical to this one. Now that's going to happen no matter what point we choose on the plane. We could let x equal 47 and y equal negative 386 and figure out whatever z is, follow the same reasoning, and get the equation. When we expand and simplify the equation, it's going to be identical to the original. Perhaps not with the same order of terms, but with exactly the same terms as the original. And if we put it into the usual form with x first and y second and z third, it will be identical to the original.